So it's the holiday season, and I thought what better way to celebrate than to make your very own decoration. I'm going to show you how to make a Christmas tree paper circuit that's going to have a light show all programmed by a microbit. And there's also going to be some music being played by the microbit while the light show goes on. Can you guess what Christmas song that will be? If you like this video, be sure to gently hit that like button, subscribe to the channel so you don't miss anything. Alright, let's get into the build. I always like to draw a picture of what I'm going to make before I make it so I can visualize what it's going to look like. I want to make a Christmas tree that is going to be controlled by a microbit. There's going to be 7 lights, 3 blue, 3 red, and 1 yellow at the top that'll act as the star. I also want my tree to play a festive song for me. When you're using LEDs, you need a current limiting resistor to protect your LED so it doesn't burn out from too much current. To figure out the value of your resistors, there's a math equation. Yay, math! Here's what the equation looks like. R is for the resistance value we are after in ohms, Vs stands for voltage from the source, Vf is the forward voltage of the LED, and I stands for current. Remember, this is in amps, so if you're using milliamps, remember to move your decimal place to the left 3 places. So how do you get these numbers? The microbit gives off 3 volts through its output pins. The forward voltage is the minimum amount of voltage the LED needs to turn on. It's usually printed on the package that your LEDs come in. The microbit only gives out about 6 milliamps of current through its output pins, so that will be our current. After doing the math, these are the resistor values I will need. If you don't have the resistor value exactly, just use the next highest resistor value that you have. It's time to build the circuit on your breadboard and test it out. I'm putting the 3 red LEDs in parallel, that way I can turn them all on and off using one output pin on the microbit. I'm doing the same thing with the blue. The third output on the microbit will be for the single yellow LED. Hey, what do you know, my circuit works. Time to decorate the tree. You can find the Christmas tree file in the show notes below. Print out the Christmas tree on one side and the circuit diagram on the other. I printed it on a cardstock to allow for a more robust tree. You're going to need some markers to color your tree. You're going to need 3 blue LEDs and 3 27 ohm resistors. Then you're going to need 3 red LEDs and 3 180 ohm resistors. And lastly, you'll need 1 yellow LED and 1 150 ohm resistor. If you don't have a 150, you could use a 180 on the yellow as well. A pin, and of course your microbit with battery pack. A pair of scissors, a USB cable to load your code onto your microbit, and you can also power it this way too if you don't want to use batteries. 4 alligator clips, and this stuff. This stuff is so cool. It's called Maker Tape. It's electrically conductive nylon tape. You can build circuits with tape, and that's exactly what we're going to do. Quick plug, the Maker Tape and microbits are available on the Engineering Wonder store at store.engineeringwonder.show. First things first, it's time to color your tree in. Decorate it however you want. After you're done decorating your tree, grab your pin and you're going to put holes into the tree where you want your LED lights to go. You're going to need 2 holes side by side so you can slide the pins of your LED through them. I used a flashlight so I could see through the paper so I'd know exactly where they would be on the tree. After you put all your holes in the paper, grab your yellow LED and we're going to install it in your paper. You'll notice that one pin of the LED is longer than the other. That is the positive or anode side, and the short end is the negative or cathode side. Make sure you're sliding the correct pin through the correct hole so your circuit will work. Grab your 150 ohm resistor and attach it to the negative or cathode side of your yellow LED using some of that awesome Maker Tape. There are different ways to use the Maker Tape to make connections, but I found the best way is to cut off a small piece and stick it to one of the pins on the resistor and then wrap it around the pin on the LED, like this. Then bend it down along the circuit path like this. Then do that with the rest of the LEDs. Make sure you have the appropriate resistor attached to the negative, the short pin of each LED. It's time to run the ground trace with your Maker Tape. All of your resistors will connect with this ground trace. So grab your Maker Tape and attach one end to the resistor of the yellow LED and then run it directly down over that line printed on your paper. This will be the ground trace. Run your maker tape line about an inch, a half inch off the edge, and then cut it and fold it over the edge to the other side. This is where you'll clamp your alligator clip that will be connected to ground on your microbit. Then using the maker tape, connect all your resistors to this ground line, so your circuit looks like this. Attach one end of your maker tape to the positive end of the yellow LED, and then stick the maker tape to your paper, running it down the circuit line printed, and again leave about an inch to a half inch off the end, cut it, fold it over the paper. This is where we're going to clamp our alligator clips. Then do the same for the red LED right below it, again folding over the maker tape. Skip the middle blue LED for now and move on to the bottom right red LED and attach that positive end of the LED to the positive trace that you just ran with your maker tape. Then move up to the top left blue LED and attach your maker tape to the positive end and run your maker tape trace down to the bottom of the paper and fold it over like you've been doing with the others. Skip that middle red LED for now and go down to the bottom left blue LED and attach some maker tape to the positive end of your LED and connect it to the positive trace that you just ran like this. For the middle two LEDs, we're going to need to do something special. You're going to need some Scotch tape or some electric tape because we're going to make a bridge over the center ground line. This way you can run your positive traces over the ground line without making an electrical connection. Put a small piece of Scotch tape or electrical tape over the ground trace that you put down where you want your positive traces to cross. Then attach your maker tape to the positive end of the blue LED and run your trace over that bridge and attach it to the positive trace on the other side of the paper. Then do the same thing for the red LED. Attach your maker tape to the positive end of the LED, run it across the bridge, and attach your maker tape to the positive red trace on the other side, like this. And your circuit should look something like this. Next up, time to code your microbit. Hey, we're in my computer. So I already wrote the code, but I'm going to go through the code line by line so you know what each and everything does. In our onStart block, we have set audio pin enabled to false. What this does is if you don't have it enabled, so we're going to take this out. We'll take that out. You can see over in the simulator, so you could connect pin 0 to the positive end of headphones and the ground to the ground of your headphones, and you can actually listen to the music coming out of your microbit through headphones. So if you don't do that, if you don't disable it by putting in this set audio pin enabled to false, you won't be able to use it as an output for your lights. I thought it would be fun to put a little Christmas tree on the LED display so we know that the program is running. So this is the main part of the program when the A button is pressed. This is the code that runs. This plays the song and does the light show. So we're going to turn on the star, which is the yellow LED first, and then we're going to go into the song. And this is "Oh Christmas Tree" written out. It repeats the same part from here to here twice. So that's why I put it in a loop there. And I turned on and off lights depending on when I thought it would be cool to the music. And then it goes outside of that loop and it finishes the song down here. And how did I know? Oh, and then at the end there's a little twinkle of the yellow one, which is the star at the top. How did I know how to make a song? Well, I went on the internet and I found the sheet music for "Oh Christmas Tree." And I do know how to read music, but you really don't have to read music. It's because if you get beginners music, it has all the notes above the notes here, and these are single notes, so this gets held for 1 beat. This is an eighth note, which gets held for half a beat, 1 beat, 1 beat, half beat, 1.5 beats, half beat. And you can change your note by clicking here, and you have a piano keyboard. You can change your note, and then you can change the duration of how long it's held. 1 beat, half beat, quarter beat, eighth beat, 16th, 2 beats, 4 beats. We have another on button pressed. When B is pressed, it turns everything on. So if you don't want to go through the whole song, you can just turn them on. If you press A and B together, it turns everything off, so you can have all the lights off. And when you touch the touch-sensitive logo, the yellow one, the yellow light, will blink rapidly, kind of like a twinkling star at the top of your tree. I'm going to leave the link to the MakeCode project in the show notes so you can get all the code there. Let's load this onto your microbit. So first, grab your USB cable and your microbit and connect to your USB port. Then you plug this end into your computer, and we download the code right here to downloads, and we're going to find our code, the hex file here, and drag and drop it onto the microbit. Unplug our microbit, and we'll take our microbit back to the workbench and we'll test it, see how it works. Have those alligator clips handy and take the yellow one and attach it to the far left connection. Then take the red one and attach it to the one next to it. Then the black one, which is the ground, goes in the middle, and the blue, or the green in this case because I don't have a blue alligator clip, goes in the far right like this. The red alligator clip connects to pin 0 on your microbit. The blue, or in this case green, connects to pin number 1, and the yellow alligator clip connects to pin number 2. The black alligator clip, which is ground, of course, connects to ground. Then grab your battery pack and connect it to your microbit, or you could power this through the USB connector as well. This is where your hard work all pays off. I hope you had fun learning how to make your very own holiday paper circuit with me, programmed by your microbit. If you do make one, be sure to take pictures or video and tag me in it because I want to see it. I love seeing other people's projects and what they come up with. If you like this video, be sure to hit the like button, subscribe, and be sure to check out my other videos. I got a ton of other cool projects in the works as well, so stay tuned, and I will see you in the next project.